Welcome back. In the last class, we had seen the Opamp applications part. We had seen integrator, differentiator, multivibrators, right? Now, the next application, this is chapter 4. Opamp and its applications. The topic is sinusoidal oscillators. Okay, now actually I can start with Barkhausen criteria and we can see different circuits which are satisfying Barkhausen criteria, but I don't want to start directly what is Barkhausen criteria and see the circuits. I want to derive or I want to explain in a different way what is Barkhausen criteria with respect to a negative feedback system. Then we will see the points associated to Barkhausen criteria. Okay, just write down. I'm explaining, or I can say kind of derivation of Barkhausen criteria. Instead of directly saying what is Barkhausen criteria, I'm just trying to derive, not completely, I can say partial derivation of Barkhausen criteria. Therefore, we will understand clearly, and based on this I can say what is gain margin and phase margin. Okay, now write down. Let us consider a feedback system. Let us consider a feedback system. Let us consider a feedback system with open loop gain A. Let us consider a feedback system with open loop gain A and feedback network beta and feedback network beta. Okay, listen, we are considering a feedback system with open loop gain A. This is what is having open loop gain A and beta network, which is passive network. Therefore, this is your output, and let us say this is what is kind of negative feedback, what it may be. Based on the phase shift, we can say whether it is negative feedback or positive feedback. Now, right, now this is what is your output. Let us say this is what your V0 and this is what your Vi, and people call this as feedback network, feedback quantity Vf, and this is what is error voltage E of t. What is error voltage? Input voltage minus feedback quantity. Therefore, this is Vi minus Vf, and this is what is open loop gain, and this is what is your output. Okay, then I told you, right, now I want to explain system stability. If I say, if I represent equivalently, right, this is what is your system, this is what your system, let us say this is what is your system, this is what your closed loop system, this is closed loop system, this is what is closed loop system, okay, defined with V0 and Vi, whether this is stable or not. That is what, right, people consider to explain from what? From loop gain. You remember I already spoke about this. If you want to speak about system stability, people always consider loop gain. That is what I told. Even though it is having open loop gain, feedback network beta, we can convert into a open loop system with unity gain feedback. I already told, right? If I'm looking for system stability, right, then if I say signal is bounded here, surely this is also bounded. Definitely input is bounded, because only for bounded input we are checking whether output is bounded or not. Therefore, this is bounded, this is bounded, I can say this is also bounded. Intermediate to your open loop amplifier, that is also bounded. Therefore, if you want to speak about system stability, you can take a node in a closed loop system. If that node is bounded, 90% or maximum, I can say the overall system is stable. Therefore, if you want to speak about the system stability, then you can take any node and then speak about whether it is bounded or not. Now, if I convert into, this is what your closed loop system, right? Therefore, if I convert into, therefore, converting into unity gain feedback system. Unity gain feedback system. Therefore, if I convert into unity gain feedback system, how can I write? Let me make this as A beta. This is what people call it as loop gain. Therefore, I am just converting into A beta. Now, this is what is our plus minus. Okay, this is unity gain. This is your something, some output. This is what is your output. Some node. This is your output, and this is what your input. Can I write like this? Right, I can write like this, right? Whatever it may be, if you see here, this is what is our loop gain. When I say this is what your loop gain, A beta, it is associated with what? It is associated with magnitude, and it is associated with some phase angle. That is what is magnitude response and then phase response. But this is for loop gain, because what is loop gain? A beta into 1 is nothing but loop gain. Here what is loop gain? A into beta. This is what your loop gain, because this is what is converted into unity gain feedback system. Because all the techniques, whatever we studied in control systems, right? I'm just repeating the same sentence again. Like Routh-Hurwitz criteria, root locus, Bode plot, polar plot, Nyquist criteria, all are valid only for unity gain feedback system. Okay? Therefore, converting any system into unity gain feedback system, but remember, when you say this is what your output, but your output with respect to this, when I say V0, V0 is intermediate to it. Therefore, I am not bothering about output, I am bothering about system stability. If I am bothering about system stability, any node is okay for me, therefore I can continue. Later on, if I know this voltage, means indirectly, this is nothing but this feedback quantity. If I know this voltage, if you know beta, can't you find V0? Yes, we can find V0 also, right? That is what it is. Now take it, I want to take either this or this, anything is fine, but we have to convert, we have to ultimately consider A beta, that is nothing but your loop gain, okay? Just take it, then I'm going to consider this, and let me explain 4 conditions. Out of 4 conditions, the last condition is the one which is what is going to give you oscillations, sustained oscillations. Okay, I'll explain that part because I need space. If I start explaining here, I want actually 4 columns, therefore we can compare easily. Okay, take it. You can say I'm explaining principle of oscillations. See, with respect to oscillations, if you are getting oscillations here, definitely you will get oscillations here, right? But it depends on the peak to peak. That is fine. I want oscillations. To get oscillations, whether I will take output here, I will take output here, or I will take output here, doesn't matter for me. Okay? But normally we will not take output here because it is almost tending to 0 if A is very high. That's why either you can take here, you can take here. If you convert into unity gain feedback system, That is nothing but A beta taking here. This is nothing but your output. And then feeding back. This is what is feeding back. That is what. Anything is fine. Okay. Remember, that's what. For oscillations, you can use either this or this. Either you can get oscillations here or you can get oscillations here. That is what. Both are same. But this is what the technique we use, or this is what we apply for your control systems, where we consider unity gain feedback system. Okay. Done. Now write down. Let us take open loop system A. Let us take open loop system A. Let us take open loop system A phase shift. Open loop system A phase shift 180 degrees. Therefore, let us say this is what is providing 180 degrees phase shift. Therefore, this is giving 180 degrees phase shift. Okay, means angle of A. Therefore, instead of saying A, this is what angle of A is 180 degrees phase shift. You will understand the meaning of this, because if you consider common emitter amplifier, that will give you 180 degrees phase shift. Common source amplifier, 180 degrees phase shift. Inverting amplifier, we can get 180 degrees phase shift. What do you mean by 180 degrees phase shift? Minus 100, minus 10, minus 20. That minus is indicating inversion, or 180 degrees phase shift for sinusoidal signals. Okay. Now let me explain 4 cases. Okay. Okay. Let me erase this, then I'll take 4 cases, then finally I'll explain the principle of oscillations. I'm going to consider the unity gain feedback system. Okay. Now case 1, let us consider mod A beta. Mod A beta is nothing but loop gain. Loop gain greater than 1. Case 2, loop gain less than 1. Case 3, loop gain is equal to 1. Case 3, A, 3B, loop gain is equal to 1 without any input. That is what I am going to explain. Okay. Now let's see. Example, what do you mean by mod A beta greater than 1? Let us say this is what is your A beta. This is your A beta, which is loop gain. Okay, which is G of S. Then let us say this is what is plus minus and having unity gain feedback. Okay, and this is what your V0, let us say, and this is what is your Vi, and this is error voltage E of t is equal to Vi minus Vf, and this is what is feedback quantity Vf. Okay, this is what is your open loop gain. Then let us say this is what is having phase shift. Okay, this is what is having phase shift angle A beta, right? This is what is having phase shift angle A beta is equal to 180 degrees phase shift. Okay, now tell me, let me apply bounded input. If I apply bounded input, what am I expecting? Let us see. Therefore, I am applying bounded input. Let us say I am applying 1 volt sine wave, 1 volt peak to peak sine wave. This is what is your Vi, and this is what is time axis. Therefore, this is nothing but 1 volt peak to peak. Is it bounded input? Yes, this is bounded input. Okay. Now we need to get, if output is bounded, then bounded input, bounded output, system is stable. What type of feedback it is, whether it is negative feedback, positive feedback, no feedback, doesn't matter. With respect to input and then output, if you want to comment on system stability, the fundamental definition of system stability is nothing but what? If I give bounded input, I should get bounded output. If I give bounded input, if I get bounded output, system is stable. Okay, fine. Therefore, I am giving bounded input. I am expecting what is output, right? Therefore, let us consider mod A beta greater than 1. When I say mod A beta greater than 1, example, can I say greater than 1? Let me take mod A beta. It is, you can take, it's better to have 10. Therefore, multiplication is easier. Therefore, let us consider mod A beta is equal to 10. Therefore, what is mod A beta? Mod A beta is equal to 10. Mod A beta is equal to 10. Strictly speaking, A beta is equal to minus 10. What do you mean by minus 10? Having 180 degrees phase shift and gain of 10. But I'm just separating. This is magnitude response and this is what is phase response or phase angle, which is 180 degrees for this sine wave. Okay, whatever sine wave you are applying, for that sine wave, let us say this is what is giving 180 degrees phase shift and then having a gain of 10. Okay, now listen. Initially, let me start with, initially the output is 0 volt peak to peak. Remember, whenever I say 1 volt, 2 volt, 3 volt, 4 volt, means 1 volt sine wave peak to peak, 2 volt sine wave peak to peak, 10 volt sine wave peak to peak. I am speaking about peak to peak quantity. Okay, now let's analyze. What is input? 1 volt peak to peak. Then what is your feedback quantity? Now the feedback quantity, whatever output, that is what your feedback quantity. That is also 0. Now tell me, what is your input? Input is nothing but 1 volt peak to peak. 1 volt into 0 initially, not into 1 volt minus 0. That is what is error voltage. Therefore, what is error voltage? VI minus VF. VA is nothing but 1 volt. VF is nothing but initially 0. Therefore, this is also 1 volt peak to peak. Then 1 volt into 10. What is 1 volt into 10? Therefore, whatever input you are giving into 10, that is what is 10. But it is having phase shift of 180 degrees. How will you represent that 180 degrees? Minus 10. Therefore, now what are you getting? We are getting minus 10. Now that minus 10 is sampled and fed back. You are getting minus 10 here. Now, what is your input? Input is always bounded, which is 1 volt. 1 volt peak to peak. Therefore, 1 volt minus 10 volt. Sorry, 1 volt minus 10 volt. Therefore, this is 11 volt. 11 volt into 10, 110 with phase shift of 180. Therefore, minus 110. Then 110 is sampled and fed back. Minus 110. 1 minus of minus 110. 111 volt. 111 into 10. Minus 1110, etc. This is what is your output. Therefore, tell me if you plot your output. Therefore, what is your output? 0. Then immediately minus 10. It is like 10 times. Right? This is your output. This is your V0. Therefore, now tell me, it is like increasing, like for every sine wave, it is increasing 10 times. Because we have taken mod A beta is equal to greater than, it is greater than 1, we have taken 10. Whatever it may be, bounded input, is it bounded? No, it is not bounded. Therefore, this is not bounded output. Therefore, it is unbounded output. Unbounded output. Is system stable? No. Therefore, system is not stable. System is not stable. System is not stable. Therefore, what do you mean by this? When I give bounded input, we are getting unbounded output. Therefore, whatever it may be, right, your system is unstable. Can you say that? Yes, system is unstable. Now, similarly, case 2. Case 2. Let us say mod A beta less than 1. Example, mod A beta is equal to, let us say, 0.1. It is easy. Whenever you want to multiply, just take one decimal to the left. Now the same thing we need to analyze. Okay. Now again, let us consider the same thing. This is nothing about your A beta, which is nothing but loop gain. Okay. And this is what is our, and having negative feedback, unity gain feedback. And this is your V0, and this is your Vi, and this is error voltage E of t is equal to Vi minus Vf, and this is what your feedback quantity Vf. Okay. Now what is the phase shift? The phase shift of your open loop system or loop gain. Let us say this is what is 180 degrees. Whatever maybe I am just taking it as 180 degrees. And what is mod A beta? Mod A beta is equal to 0.1. Okay. Now let us take 1 volt peak to peak. Same thing. Therefore, I am applying 1 volt peak to peak sine wave. Fine. And this is Vi. Let us say 1 volt peak to peak. Again, this is what is bounded input. This is bounded input. Okay. Now let's see. Let me start initially the output voltage 0. Then what is your feedback quantity? The feedback quantity initially, that is also. Therefore, this is what is our feedback quantity Vf. Therefore, initially that is also 0. Now what is your input now? Input is 1 volt peak to peak. Input is 1 volt peak to peak. 1 minus 0. Therefore initially what is error voltage? Initially arrow is indicating the initial voltage. Okay. 1 minus 0, that is 1 volt. Therefore now tell me 1 volt into 0.1. 1 volt into 0.1. Definitely 0.1, but with phase shift of 180. Therefore can I say that is nothing but minus 0.1. That is minus 0.1. Now that minus 0.1 is fed back. Okay. Now input is always 1 volt peak to peak, which is bounded. Therefore 1 minus of minus 0.1. This is 1.1 volt. 1.1 into 0.1 minus, because 180 degrees, therefore minus 0.11. That you fed back minus 0.11. 1 minus of minus 0.11. It is 1.11 volt. 1.11 into 0.1 minus 0.111. Therefore, etc. If you plot your output, this is what your time t, then 0, right, 0.1, therefore 0.1, it is increasing, but it will be almost, it will be settled in between I hope you are understanding, you are trying to track what I am trying to say, right? Therefore it will be in between, right? Now it will be definitely the peak to peak, right? Less than 0.12, right? 0.111, if you take to up to infinity, 0.11111111, definitely less than 0.12 peak to peak, right? Magnitude. Therefore this is your output V0. Is it bounded? Yes, this is bounded. Therefore this is bounded output. This is bounded output. Therefore now tell me, what, system is stable or not? Yes, system is stable. System is stable. System is stable, right? Write down. I'll give you case 3, mod A beta is equal to 1. Then again let's analyze, right? Then under case 3 we'll get 2 sub cases. Case A, case B under case 3. Case A same as 1, 2. Case B without input. That part I will explain. First of all take these two, then I will explain case 3. That is nothing but mod A beta is equal to 1. I want space basically, I don't want waste, therefore I want to split it like this, okay? Now case 3 mod A beta is equal to 1. What is example? That itself is 1, okay? In that case, I can say case A. These are all case A's only, whatever may be. Whether case A, case B, the observation whatever I told, that won't change. That part I'll explain when I complete this, right? With input. With input. Then case B without input. That is what I'll try to explain. Therefore, that is nothing but case B without input. Without input. When I draw all these things, you will understand, okay? Again, I need sub cases, okay? That is what I'll draw it later. But anyway, I want this, okay? Now, maybe after completing this, you have to write. Therefore, now this is what is your A beta. This is A beta, and this is your output, and this is what is your unity gain feedback, and this is feedback quantity, and this is what your VI, and this is error voltage. E of t is equal to VI minus VF, okay? And this is what is the feedback quantity VF, okay? Now, okay, first of all complete this, then I'll explain here also. Therefore, here also, this is what is your A beta, and this is what is our plus minus, okay? I have space to the right. And I can take to right. This is A beta. This is V0, okay? Now this is VI, and this is error voltage E of t is equal to VI minus VF. This is what your feedback quantity, okay? Now I'll come to this part. Here what is the meaning of with input and what is the meaning of without input? Actually with input, input means bounded input. In both the cases, case 1, case 2, we gave bounded input, but in case A here also with input means bounded input, but here there is no input. Input is not there continuously. Okay, you take it. Observations are important. I want to complete all 3 cases one shot on the board. Reason, we can have the comparison. Okay. In all the cases, the phase shift by A beta is 180 degrees. That is what we considered. Okay. But I'll explain. I'll come back to this. We should consider actually the total loop phase shift. But now I'm taking A beta is giving 180 degrees phase shift. Okay. Like common emitter amplifier. Okay. With feedback system or open loop amplifier, example, inverting amplifier, right? That is what all. Once I explain the different types of oscillators, then you can correlate all these things. Whatever it may be, ultimately, loop gain, that is what is important, and loop phase shift, that is what I am going to comment on. That will give you principle of oscillations. Okay, fine. I'll give you one more minute, try to complete. Then we will see case 3A, case 3B. Again, I'll give you time for this. You try to complete case 1, case 2. Okay. Therefore, when A beta is having 180 degrees phase shift, and if you consider the system with like plus minus, and if the loop gain is greater than 1, system is not stable. If loop gain less than 1, system is stable. If loop gain is equal to 1, we are going to comment on system stability. Okay, let's see. Hope this is done. Done? Okay. Now let's see case 3, right, with input. When I say with input as it is, therefore let us give input. This is sine wave. This is what is there. Now this is Vi, therefore 1 volt peak to peak. Okay, this is also bounded input. Bounded input. Okay. Now let's see what is mod A beta. Mod A beta is equal to 1. Mod A beta is equal to 1. And what is the phase shift? Angle of A beta is equal to 180 degrees phase shift. Okay. Now initially let's start with 0. Therefore initial output voltage is 0. Then what is our feedback quantity? That is also 0. Okay. Now let's see what is input now. 1 volt. Therefore 1 volt minus 0. 1 volt. Therefore the initial voltage is 1 volt here. 1 into 1. 1, but with phase shift of 180 degrees. Therefore it is minus 1. That minus 1 is fed back here. Therefore now tell me, this is 1. 1 minus of minus 1. This is 2 volt. 2 into 1 minus 2. That minus 2 is fed back here. Therefore 1 minus of minus 2, you will get 3 volt peak to peak. 3 into 1, you will get minus 3 volt peak to peak. Continuing. Therefore tell me what is your output. Now if you plot your output is 0, minus 1, minus 2, minus 3. It is increasing linearly. This is your output. But is it bounded? No, it's not bounded. Therefore it is unbounded output. This is unbounded output. Okay. Now I'll not comment on system stability. Just wait. Okay. Let me complete the other one. Now without input. What do you mean by without input? But I'm assuming something, but I'll correct it later. It's not correction. I'll explain the meaning of it. Input is there for some time. Therefore same thing. Mod A beta. What is mod A beta? 1. Angle of A beta, which is 180 degrees phase shift. Now let us say input is there. Let us say input is present only for 1 cycle. Later on input is not there. Okay. This is your VA. Therefore what is initial voltage? Initial voltage is 1 volt peak to peak. Okay. This is what your initial voltage. Now let's see. What is initial voltage? Output voltage, let us say 0. Then what is initial voltage? Feedback 0. What is initial voltage? This is 1 volt peak to peak. 1 volt minus 0. Therefore initial voltage here 1 volt. Right? Therefore tell me 1 volt into 1 minus 1. That minus 1 is fed back here. Now let us say what is input? Now input is 0. There is no input. Right? Therefore now there is no input. If there is no input, that is the meaning of without input. Input is not continuous. Let us say input is there for some time, then input is not there. Input is there momentarily, then input is not present. Let us say. I'll explain the meaning of it. What is the meaning of input is there for some time and then input is not there, and then considering that input is not there at all. Okay. I'll come back to that point. Therefore this is minus 1. Then 0 minus minus 1. It will be 1. 1 into 1 minus 1. You fed back 1. Then now this is 0. 0 minus of minus 1. 1 volt. 1 into 1 minus 1. This is what is continued. Therefore if you ask me what is your output is 0 minus 1. Therefore you are getting constant 1 volt peak to peak. Therefore is it bounded? Yes, it is bounded, but there is no input. Therefore there is no input. Therefore this is what is bounded. Your input, therefore kind of what? There is no input, without input. This is what is without input. but input is there for some time, and then later on input is not there at all. Input is completely zero, but momentarily input is there. Okay, that is fine. Therefore, ultimately if you see, there is no input, there is output which is there, which is continuously a sine wave, which is 1 volt peak to peak in this example. Okay, therefore this is what is without input. Therefore, if you observe clearly, in every case 1, case 2, case 3, but case 3 we have seen case A, case B. Similarly, we have to see case A, case B, case A, case B. But observation is same. Why? Just listen. I'll give you time to write down. Just listen. Observations are important. So for now, case A with input, which we did already, unbounded output. Case B without input. Then input 1 volt initially there, later on input is not there. Even if you do that, it will be unbounded. Whether input is present or input is not there, your output is always unbounded. Therefore, it is always unstable. Now, case 2, whether input is there or input is not there, always your output is bounded. Therefore, system is always stable. But here, when loop gain is equal to 1, if input is present, unbounded output. If input is not there, you are getting bounded output. Therefore, this is what is called, because with respect to your input, if input is there, it is unbounded. If input is not there, it is bounded. Therefore, but here, whether input is there or input is not there, it is always unbounded. Whether input is there or not there, it is always bounded. But here it is with respect to input. Therefore, this is what people call it as marginally stable system. This is what is marginally stable system. This is what is marginally stable system. When loop gain is equal to 1 and phase shift of 180 degrees and then plus minus, if you consider this type of system, then this is what is called marginally stable system. In marginally stable system, if input is present, your output is unbounded. If input is not there, your output is bounded. Okay, but I'll explain the meaning of input is present for some time, then ultimately your input is defined as 0. That part I'll explain. Actually, that is what people say noise. Noise is the input for your oscillator. Therefore, but whatever maybe input is not there, if there is no input, but what is the input? Noise is the input, then you'll get output, which is nothing but your sinusoidal oscillator. Therefore, I'm going to take this and I'm going to explain the principle of oscillations, basically Barkhausen criteria. And based on this, based on all these things, remember case 1, case 2, case 3, remember I'm going to explain what is gain margin, what is phase margin. Once you understand these two, okay? That part I'll explain. You take it. And an important note, as you go on, you'll understand, when I say phase shift 180 degrees, this will not give you 180 degrees phase shift, right? For all frequencies, it will give you 180 degrees phase shift for a given frequency. If you take total loop gain, okay? Because A can give 180 degrees phase shift for some range of frequencies, but beta cannot give because that is passive network. It depends on resistor, inductor, capacitor. All are reactive components. Then definitely frequency sensitive. Then phase shift is also depending on frequency of your input signal. Therefore, only for a given input signal frequency, the A beta will give you 180 degrees phase shift, and the total loop phase shift will be defined something. Therefore, that will be the frequency I'm speaking about. I'm taking indirectly and then commenting on all these conditions. Okay, you'll understand, because everything if I explain at the same time you will not understand. Therefore, incrementally I'm explaining. But take it, in all the cases, loop gain is nothing but A beta. In all the cases, the phase shift by A beta is 180, 180, 180, 180. And we have, I just represented like negative feedback. Okay, fine. But overall it is positive feedback. Why it is positive feedback? I'll explain. Because of plus minus, and this is 180. Okay, overall it is 0 degrees or 360 degrees, which is what is positive feedback. Okay, that part we will see. That's why in control systems, people always consider 180 degrees as reference. Because in control systems, if you consider unity gain feedback system, this is nothing but G of S, right? Which is open loop system. For G of S only, you are going to draw Bode plot. For G of S only, you are going to draw polar plot. For G of S only, you are going to take root locus. For G of S only, we are going to take Nyquist plot. But Routh-Hurwitz criteria, we are going to take characteristic equation of closed loop transfer function. Okay, but ultimately that is also going to your open loop gain. What it may be, whether root locus, Bode plot, polar plot, Nyquist criteria, right? For all closed loop systems with unity gain feedback, we always consider 180 degrees as a reference, and mod A beta greater than 1, less than 1, equal to 1. 1 is always a reference. With respect to magnitude, 1 is reference. With respect to phase shift, 180 degrees is reference. Remember, I am going to use these two to explain gain margin and phase margin. You can imagine that this is loop gain or G of S. This is G of S, G of S, G of S with unity gain feedback system. Okay. I'll give you 2 more minutes. Try to complete case 3. I gave you already time, sufficient time for case 1, case 2. Now I'm giving you time for case 3 and A and B. Under case 3, A and B. Any doubts? I'm just going like case by case, therefore should not have any doubts because I'm explaining clearly. Once you understand principle of oscillations, the circuits what we consider for sinusoidal oscillators, right? All are straightforward. You will understand, okay? Done? Okay. Therefore, I'll come back. The meaning of input is present for some time and then input is not there. Actually, that is nothing but noise. Noise is there, then later on noise is not there. Actually, noise is the one which is what is the input. When I say noise, it could be external coupling noise, it could be power supply noise, it could be thermal noise, it could be some transistor noise, could be anything but noise, a disturbance in the circuit. That is what is going to create oscillations. That disturbance is nothing but input. That is what it is going to take and then boost it and then try to get your oscillations. I'm going to give you the practical considerations also, but I'm going to consider case 3 mod A beta is equal to 1 and without input. I'm going to explain the principle of oscillations. Okay. Let me consider the case 3B. Let me erase everything. Just 2 minutes. After that, the session is over. Okay. Let's see. Now can I write the system like this? Now input is equal to 0, right? When input is equal to 0, therefore what is the error voltage? Vi minus Vf. Therefore, when Vi is equal to 0, this is what your A beta, and if you see here, what is your error voltage? Your error voltage, because Vi is equal to 0 under steady state, then error voltage is nothing but 0 minus the feedback quantity. This is your feedback quantity Vf. Therefore 0 minus Vf, which is minus Vf, right? Therefore what does it mean? Can I equivalently write it as like minus Vf means, can I write it as, this is nothing but your A beta, and now whatever you are getting, just to represent, can I make it like minus 1, just modeling, and then directly giving as the input here, right? And this is what your output, let us say. Then tell me what is that? This is nothing but what? Vf. Vf is nothing but V0 only. Therefore, what is feedback quantity? This is what your feedback quantity. Just sampling your output, and then this is what is minus Vf. That is what you are feeding here. Therefore, this is what it is. Right? Maybe ultimately if I go back, this is what your loop gain, right? Or when I say this is what, and we know that this is what angle A beta is nothing but it is giving 180 degrees phase shift and having some loop gain. It could be greater than 1, less than 1, or equal to 1, what it may be. Therefore now, and this is what is giving, this is giving 180 degrees phase shift. What is the meaning of minus 1? 180 degrees phase shift. Then tell me what is the total loop phase shift? Now the total loop phase shift without input, right? The total loop phase shift is 0 degrees. At what frequency the total loop phase shift is 0 degrees? That is what is called frequency of oscillations. Whether you get sustained oscillations, over damped oscillations, under damped oscillations, that depends on the total loop gain. What is the total loop gain? Mod A beta into mod 1, mod A beta. That is what is your loop gain. I am going to explain the principle of oscillations. Okay. The session is over. You can pause the video and then you can take this. But I am going to, based on this one, I am going to give you the principle of oscillations. Okay, we will continue in the next session. Thank you.